When you first hear the words addition or subtraction, your initial instinct is usually to think that the math will be straightforward. However, when it comes to fractions, addition and subtraction can be much more complicated than multiplying or dividing, especially when it comes to rational expressions. Unlike multiplying or dividing, you need your expressions to share a common denominator before you can add or subtract. The following examples in this slide only will already have a common denominator, so at least for now, that will be one less math step that we will have to be concerned with. Let's begin by looking at this first example. Because of the shared common denominator, we just need to combine our numerators. We can do so, and I would suggest always putting in parentheses, even if it's not going to be necessary. And now you combine like terms, where the 2x and the 5x can be merged together, and the positive 3 and negative 8 can be merged together, and we will be left with the quantity 7x minus 5 all over the quantity 9x minus 1. The next two problems are dealing in subtraction. In this case, we have the quantity 6x plus 5 all over x plus 7 being subtracted by the quantity x minus 8 all over x plus 7. As I stated before, you can merge the two fractions into one. This time, I really recommend that you use parentheses. Why? Because the biggest issue is that students forget to take the negative and distribute it over the x and distribute it over the negative 8. If you do that, you would realize that your numerator is now 6x plus 5 minus x plus 8. And when we combine those like terms, we will get 5x plus 13 all over x plus 7. Let's practice one more subtraction problem in which our rational expressions already share a common denominator. When we rewrite it as one fraction, I highly recommend you put parentheses around the first numerator, then put your subtraction symbol, and then write parentheses around the second numerator, so that it helps you remember that you need to distribute the negative not only to the 2x, but also to the positive 5. So when you do rewrite the numerator without parentheses, and you come up with 3x plus 8 minus 2x minus 5, and then you combine those like terms in the numerator, and come up with x plus 3 all over x squared minus 9, you're good to go. Or are you? This particular problem is different than the other ones because we are not done. We always have to consider the possibility that there may be more factors that could be canceled out. X squared minus 9 is a difference of two squares. Its factors are x minus 3 and x plus 3. And since there's an x plus 3 factor in the denominator as well as in the numerator, it can be canceled out and you are left with 1 over x minus 3 as a simplified expression. In this example, our rational expressions do not share a common denominator. The first fraction's denominator is the quantity 2x plus 5. The second fraction's denominator is the quantity x minus 7. You cannot add rational expressions together until they share a common denominator. In order to do so, we will need to multiply each fraction by a specific expression that is equivalent to 1. Remember, this process will allow us to change the appearance of a fraction, but not, for the sake of simplicity, let's call it a value of the expression itself. Although you could have any shared denominator, I recommend trying to find the least common denominator whenever possible. Fortunately for us, that will require multiplying the first fraction by the quantity x minus 7 over the quantity x minus 7, thanks to the second fraction's denominator. Just as we will multiply the second fraction by the quantity 2x plus 5 over the quantity 2x plus 5, that coming from the first fraction's denominator. Now what we need to do is FOIL that first numerator and distribute the 6 in the second numerator. And let's combine the two fractions to 1 using parentheses. But we're going to remove those parentheses, and since it is an addition problem, that will not require any additional work. You will combine like terms, and you will have yourself a simplified answer of the quantity 3x squared minus 13x plus 58, all over the factors of 2x plus 5 and x minus 7. Now, you do not need to multiply those two factors together. In fact, I recommend you don't, on the off chance you may need those factors later on. It's possible you might have to simplify the numerator and then might have to cancel out some factors. This problem cannot be factored any further, and therefore it is now simplified. Our next example involves subtraction in which the rational expressions do not share a common denominator. Given that there are quadratic polynomials in both denominators, we should factor those quadratics first to see if there are any shared factors. In our first fraction, we can factor x squared plus x minus 2 into the quantities x minus 1 and x plus 2. The second fraction's x squared minus 4 can be factored as x minus 2, x plus 2. As both denominators share that same quantity of x plus 2 as a factor, we do not need to multiply each fraction's top and bottom by another quantity of x plus 2. Because we'll avoid this step, we will be using the least common denominator, which in return will make the rest of the simplifying process easier. Since the second denominator has a quantity of x minus 2, which is not found in the first denominator, we will multiply the first fraction by the expression of x minus 2 all over x minus 2. A similar issue arises as the first denominator has a quantity of x minus 1, but the second denominator does not. So the second fraction will need to be multiplied by x minus 1 all over x minus 1. FOIL the first fraction's numerators to come up with x squared plus 3x minus 10 and put parentheses around it. Distribute the 3 in the second fraction's numerator to find the binomial 3x minus 3 and put parentheses around that. We combine the two fractions together, putting a minus symbol between the two quantities found in parentheses. Now when we remove those parentheses, remember that the negative must be distributed to both positive 3x and positive 3, giving us an unsimplified numerator of x squared plus 3x minus 10 minus 3x plus 3. Combine the like terms and your simplified result is x squared minus 7 all over the quantities of x minus 1, x plus 2, and x minus 2. Again, I would leave your denominator as it is. It is not necessary nor recommended to remultiply your factors into a cubic polynomial. This example, in which we are subtracting a rational expression from another rational expression, was specifically selected as it requires us to do more work up front in finding the least common denominator, which you will find later is much more preferred than having just any common denominator. We'll begin by factoring our two denominators. We'll start with 8x plus 64 and realize we can pull out a greatest common factor of 8, leaving us a quantity of x plus 8. Just as we can pull out 2x from our second fraction's denominator, leaving us a quantity of x plus 8 as well. Now, if we remember that 8 can consist of both a 2 and a 4, and 2x consists of a 2 times x, we actually already have the parts of 2 and quantity x plus 8 in both fractions. Therefore, the first fraction really only needs to be multiplied by x over x, just as the second fraction only really needs to be multiplied by 4 over 4. When we simplify each of the numerators, we come up with 3x squared minus 28. Now, in this one particular problem, if we remove the parentheses, it's really not going to make much of a difference. And in fact, we come up with our final simplified expression, the quantity 3x squared minus 28, all over 8x times the quantity x plus 8. Warning! The following work demonstrates what happens when you don't find the least common denominator first. The work is correct, but may not be suitable for all. Viewer discretion is advised. This example, in which we are subtracting a rational expression from another rational expression, was specifically selected to demonstrate what happens if you don't find the least common denominator. So, feel free to multiply the first fraction's top and bottom by the second fraction's denominator, 2x squared plus 16x. Feel free to multiply the second fraction's top and bottom by the first fraction's denominator, the quantity 8x plus 64. You can go ahead and distribute. Of course, you'll remember to put parentheses around the 6x cubed plus 48x squared. Then you'll put a subtraction symbol. And then you'll remember to put parentheses again around the 56x plus 448. When you decide to remove those parentheses, you'll remember to distribute the negative to the 56x and the 448, coming up with a numerator of 6x cubed plus 48x squared minus 56x minus 448. Now, maybe you'll decide to take out a factor of 2 because everything's divisible by 2. I took 2 out of the 8x plus 64 in the denominator. And we'll cancel out the 2's. And now you're left with a very simple little 3x cubed plus 24x squared minus 28x minus 224, all over the factors of 4x plus 32 and the factor of 2x squared plus 16x. In order to continue simplifying, you need to select a method that will allow you to break down the numerator into smaller factors, some of which will then cancel with equivalent factors in the denominator. For this particular numerator, I would use grouping and chunking. However, in order to make it work, we need to rearrange the middle terms such that 3x cubed is subtracted by 28x and 24x squared is subtracted by 224. How did I know to use that method and specifically that order of terms? It comes from experience I've gained via plenty of practice. Now we'll factor out an x from the first two terms of the numerator and a positive 8 from its last two terms. We can then rewrite the numerator with factors of x plus 8 and 3x squared minus 28. Now when it comes to the denominator, we find that both of its factors could have been broken down into smaller factors, each having a quantity of x plus 8. But we have to realize there is only one quantity of x plus 8 that's found in both the numerator and denominator. Therefore, we can only cancel one quantity of x plus 8 in the numerator and in the denominator. Let's combine the 4 and 2x into 8x in the denominator, and we're back to the same simplified expression as before. 3x squared minus 28 all over 8x times the quantity x plus 8, which was significantly easier to find when we used the least common denominator.